hard. Okay, student, already we learnt how to express the given number in a 2 to the power n into 5 to the power m form. So taking the same question, we have to find out. What we have to find out? We have to express this number in a decimal form. The same question, if they given, it is in the form of terminating or non-terminating form. Okay, take the same question, we should express in decimal form. The first procedure, as usual, what we done for the first problem, like that only we can do. 13, given number is 13 by 3125. Call it as p by q. P is equal to 13, q is equal to 3125. What are the factors of q? That means the factors of q will be 5 power 5 into 2 power 0. These all we know the steps. V is x is equal to 13 by 3. We have a terminating decimal expansion. We have to express in decimal form. It is a terminating decimal expansion, right? It is a terminating decimal expansion, but we have to express. Okay, we have to. This is a terminating decimal expansion. We have to express in a decimal form. How to express in decimal form? The same procedure. Call it as x is equal to 13 by 3125. These steps we already learnt. What is the next step? We have to do the same question. If the asked to find, express in decimal form, the first procedure will be the same only. Then x is equal to 13 by 5 to the power 5 into 2 power 0. Then x is equal to 13 into 2 to the power 5 and 5 to the power 5 into 2 to the power 5. Why I have to multiply both the terms by 2 to the power 5, 2 to the power 5? Because here we have to make 10 in the denominator. To make the term as 10 in the denominator, we have to multiply and divide it by 2 to the power 5. 2 to the power 5 means it is nothing but 32. 13 into 2 to the power 5, we have to write 32. 2 into 5 whole to the power 5. Then if you multiply 13 into 32, you will get 416. Then 5 2 is 10 whole to the power 5. 10 to the power of 5 means we have to put 5 zeros in the denominator. Then 1, 2, 3, 4, 5. Then 416 divided by 1 lakh. You know that how to divide by tens, 100,000, lakhs. You know that, write the number as it is and how many zeros they given? 5 zeros. After 5 digits, you should put comma 1, 2, 3, 4, 5. Then x is equal to 0.0416. So the decimal form of the given number 13 by 3125 is equal to 0.00416. Okay, student, it's a very easy problem. Just we have to practice the problem, then you'll get an idea. Like another one problem we have to take and do. Okay, I'll write and explain the same problem. Same thing, we are taking the second example. What is the second example? Let us consider the problem 17 by 8. This procedure we know that already we explained this one. How to write this one? So it can be expressed as a first step for terminating decimal expansion. So consider the number, given number 17 by 8, expressed in the form of p by q. Compare with that equation. What is p? P is equal to 17, q is equal to 8. Express as the denominator product of prime factor. If we express the denominator here 8. If we express that one, 8 can be expressed in 2 to the power of 3. It is in the form of 2 to the power n into 5 to the power m, where n is equal to 3, m is equal to 0. Therefore, x is equal to 17 by 8 can be expressed as a terminating decimal expansion. Terminating means it will complete a division. So, to take the same problem, we have to express 17 by 8 as a decimal form. We have to express this as in a decimal expansion. How to express in decimal expansion? This will be also very easy. The given number we have to call it as x is equal to 17 by 8. 17 by 8, we can write the factors of 8 as in the form of 2 to the power n into 5 to the power m. So 2 cube into 5 power 0. We have to make the denominator as 10. 2 5s are 10. So what is the power here? 3 is there. So both numerator and denominator multiply with 5 to the power 3 to make the denominator as 10. Then if you multiply 17 into 5 cube, 2 cube into 5 cube. 5 cube means 125. it has same common power. We can write whole power. 2 cube into 5 cube can be written as 2 into 5 whole cube. Then if you multiply 125 into 17, you will get 2125. 5 twos are 10. Then 5 twos are 10 means whole cube. 10 cube means 1000. We know that decimal expansion, when any number divided by 1000, write the denominator as it is. From right side we have to put point after 3 digit 1, 2, 3. Then x is equal to 2 into 1, 2, 5. So the decimal expansion of the given number 17 by 8 is given by x is equal to 2.125. Like this they will ask in the exam. It's a very important problem, very easiest also. You have to glance correctly. If you have any doubt, you can ask me, and we have to practice the problem. Okay student, this is a question, exercise 1.4, the last exercise of your chapter real number. Question number 3, you have to refer the questions in your textbook. I'll tell the question also, but you have to refer once again. Question number 3, exercise 1.4. Okay, they're asking in that the following real numbers have decimal expansion as given below. In each case, decide whether they are rational or not. If they are rational, we have to express in the P by Q form. So take the first problem for 43.12. The given number is 43.1234579. What we should do, let us call it as the given number as x. 43.123456789, call it as equation number 1. X has a terminating decimal expansion. It is a rational number because here the given number is 43.123456789. So here what they are asking means we have to call it as the given number as x. X as for x is equal to 43.123456789. Call it as equation number 1. This x has a terminating decimal expansion. It has a terminating decimal expansion. So it is a rational number. Rational number can be expressed as a terminating decimal number and non-terminating recurring decimal that we learnt in the last class only. Now remove the decimal from number. How many decimal places are there after point after 1, 2, 3, 4, 5, 6, 7, 8, 9. Point after we have a 10 decimal places. Remove the point and write that remove the decimal from the number. How many decimal numbers are there? 9 numbers are there. We have to put 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, if we express this is in the form of exponential form, we have to write this number as 10 to the power of 9. So call it as equation number 2. From 2, x is a rational number and it is in the form of P by Q. Is it right? Already we said it is a terminating decimal expansion, means it is a rational number, and also it is in the form of P by Q, right? What is the value of P? P is equal to 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And what is the value of, if you compare this is with P by Q, compare this is with Q. In the place of P, we have a 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 number. In the place of Q, we have a number 10 to the power of 9. So prime factors of the denominator 10 can be written as 2 5s. 2 into 5 whole power 9. Therefore, what is the prime factors of Q? Is nothing but the prime factors of Q here 2 to the power of 9 into 5 to the power of 9. It's a very easy problem. You have to understand clearly. Here also the same thing. Exercise 1.4, question number 3. The given number here 0.1201200120012 so on. So here if you see the problem only we can tell, let us call it as given number x is equal to 0.1201200. Right, given number, call it as x. But here x as non-terminating. Have you understood? Here x as non-terminating. Therefore, it is an irrational number. Have you understood? So, it is a non-terminating. If it is a terminating, it is a rational number. It is a non-terminating, then it leads to irrational number. So, we cannot express in the form of P by Q. If it is a rational number, we can express in the form of P by Q. And it is a non-terminating also. Like that, if you take the question number 3, 43.123456789, repeating. If you put a bar means this 2, 4, 6, 8, 9. The 9 digits again it will be repeating. After 1, 2, 3, 4, 5, 6, 7, 8, again after 1, 2, 3, 4, 5, 6, 7, 8 only number will repeat. Let us call it as the given number as 43.123456789. It is clear that the given number is a rational number because it is a non-terminating and repeating. It is also rational number, but it is a non-terminating and repeating decimal expansion. If it is a terminating, we can write it is a non-terminating and repeating. Repeating means recurring decimal. Non-terminating and recurring decimal expansion. This is about your chapter real number. Still more problems we can solve about this unit. Okay student, here we can see the one more problem. Show that 1196 and 5265 are not co-prime number. It's a very easy problem we have to solve. That means find the factors of the given number by using prime factorization method. If we factorize 1196, we'll get 2 5s are 2 9s are 2 8s are 2 99s are 1323s are. Therefore, the factors of 1196 will be 2 into 2 into 13 into 23. Likewise, factorize 5265. It will not divisible by 2. That's why start with the prime number 3. So 3755 is a 585 times and 5 117 times and 117 divisible by 3 39 times. Like that, if you find out the factors, we'll get the factors of this number 3 into 3 into 5 into 3 into 3. Since these two numbers have 13 as common factor, see here have a 13 as a common factor, right student? Among the two numbers, 13 is a common factor, thus they are not co-prime number. Okay, you can see the one more problem. Obtain the HCF of 420 and 272 by using Euclid's division algorithm and verify same by fundamental theorem of arithmetic. Already we learnt in this one in last class only. So we should apply first Euclid's division lemma. So that is A is equal to BQ plus R. Use this method. If you find out 420 can be, if you divide 420 by 270, like that you will get product dividend is equal to divisor into quotient plus remainder. Like that, if you divide and go 272, again it can be expressed product of dividend into divisor into quotient. 148 can be expressed as 124 into 1 into 24. You do like this in working steps, you will get the idea. Finally, 24 can be expressed as 4 6, remainder will be 0. The remainder will be 0. The HCF of the two numbers 420 and 148 is 4. The HCF of these two numbers. This is by Euclid's algorithm, Euclid's division algorithm. Same fundamental arithmetic means if you take the number, you factorize by prime factorization method, you will get the factors of 420 as 2 into 2 into 3 into 5 into 7. Likewise, 272, the factors of 272 also 2 into 2 into 2 into 17. That means if you see this one, the highest power 2 to the power 2 into 2 to common factor here 2, the highest power will be 2 to the power of 4. So 2 to the power of 4 means we can write here 2 square. So 2 square is nothing but 4. Call it as this is 1, call it as 2. From 1 and 2 we can say that the HCF of the two given number is equal to 4. By Euclid's division algorithm also answer will be same. If you do in that method also, either you can do fundamental arithmetic theorem also, you will get the same answer. You have to understand the problem correctly, student. It's the very easiest. So like that, in this chapter we have to learn so then we can complete this chapter. It's a very most important chapter, real numbers. So what are the concepts we learned? Euclid's division lemma, algorithm. Okay, thank you. Practice more.